You won't believe what you're about to see. A wall of solid rock, hundreds of feet high, stretching for miles, standing between civilization and progress. No tunnel, no way around it, just raw, ancient stone as if the earth itself is daring engineers to try. And try they did, with nothing but human ingenuity, earth-shattering machinery, and an almost reckless belief in what's possible. American engineers carved massive highways directly through sheer cliff faces that most people said couldn't be touched. Roads that hang over 1,000-foot drops. Highways blasted into vertical granite walls. So how do you split a cliff in half? How do you turn a mountain into a road? Buckle up, because what you're about to learn will completely change how you see every road you've ever driven on. Let's start with a number, 4.1 million miles. That's the total length of roads in the United States, enough to circle the Earth more than 165 times. But buried within that figure are a few hundred miles of highway that defy easy explanation. Roads carved into rock faces so steep, so massive that even today's engineers describe the original construction as borderline insane. America's geography is unforgiving. The Rocky Mountains, the Sierra Nevada, the Appalachians, these aren't gentle rolling hills. These are ancient, brutal, unyielding walls of stone that cut the continent into isolated pockets. Communities on the other side of a cliff were effectively cut off from the rest of the country. Goods couldn't move, economies couldn't grow, and then the engineers arrived. But the real challenge was still ahead, because wanting to build a road through solid rock and actually doing it are two very different things. Before a single gram of dynamite was placed, teams of surveyors, geologists, and civil engineers spent years, sometimes decades, studying the terrain. Take the Going to the Sun Road in Montana's Glacier National Park, completed in 1932. Engineers spent nearly 10 years mapping fault lines, measuring rockfall zones, and calculating the precise angle at which a road could be cut into the cliff without triggering a catastrophic collapse. No computers, no GPS, no satellite imagery, just theodolites, hand-drawn maps, and an extraordinary depth of geological knowledge. They read the mountain itself, the color of the stone, the direction of the striations, the presence of water seeping through the rock. The planning phase alone involved hundreds of man-hours just to determine where to put the first drill hole. And yet, understanding the mountain was only the beginning. The real question was, what tools could possibly make this happen? And here's something that will stop you cold. The equipment used to carve America's most dramatic cliff roads was, by today's standards, primitive. Steam drills, hand-placed dynamite, mule teams hauling debris off ledges barely wide enough for a man to stand on, and yet the results are so precise, so enduring, that those same roads carry millions of vehicles every year to this day. The primary tool was the pneumatic drill, a compressed air jackhammer that could bore holes deep into rock at a rate that was revolutionary for its time. Workers called powder monkeys followed the drillers, carefully packing those holes with dynamite and calculating the exact charge needed to fracture the rock without triggering a larger collapse. Get it wrong and you didn't just lose the road, you lost the crew. Workers were suspended on hand-braided rope rigging hundreds of feet above valley floors, drilling and blasting day after day in conditions that modern safety standards would make completely illegal. But knowing the tools is one thing, watching them work on a sheer vertical face, that's where the story gets truly extraordinary. Picture this. 6 a.m. on a Colorado mountainside in 1924, temperature below freezing, 200 men already at work on a cliff so steep that standing on it is impossible. Half the crew hangs on rope rigging, drilling in precise patterns 1,000 feet above the valley floor. The foreman checks his calculations one final time. The drilling pattern is designed to create a controlled fracture, a blast that peels a specific section of rock away from the cliff face like a layer of skin. When the charges detonate, the mountain shakes. A section of cliff the size of a 5-story building tears loose and tumbles below. The dust clears, the crew moves forward. That's how it was done, inch by inch, blast by blast, season after season. On the Going to the Sun Road, construction sometimes advanced just 3 feet per day through the hardest granite. On the $1 Million Highway in Colorado, engineers had to rethink the very concept of a road shoulder. In several sections, there simply is no shoulder. The road ends and then there is nothing, a sheer drop of hundreds of feet. No guardrail, just open air. This wasn't carelessness, it was physics. And just when you think you understand the scale of the challenge, the real complexity begins to reveal itself. Blasting rock is one thing, building a road that lasts is something else entirely. After each blast, workers called scalers rappelled down the fresh cliff face with iron bars, manually testing every square foot of exposed rock, prying loose any section section that moved even slightly. Think about that. Men hanging on ropes against a freshly blasted wall, poking it with iron bars to find the parts that might fall on them. Dangerous, exhausting, and completely essential. Once the face was cleaned, cement was applied to seal the surface against water infiltration. Water is the #1 enemy of a cliff road. When it seeps into cracks and freezes, it expands with a force of 2,000 pounds per square inch, enough to fracture solid granite. Steel bolts up to 20 feet long were drilled into the cliff to pin unstable sections to the solid rock behind them. And where the road crossed completely vertical sections with no natural ledge, engineers built cantilevered platforms, road surfaces projecting directly out from the cliff face, supported only by steel beams anchored deep in the rock. Some of those cantilevered sections still exist today. You've probably driven over one without realizing it. Once built, the work wasn't over. It was just beginning. A road carved into a living mountain is never truly static. Rock moves, water moves. Freeze-thaw cycles and traffic vibration relentlessly work to undo what the engineers created. Early inspectors walked every inch of road surface, tapping rock with hammers and listening for the hollow sound that revealed a void beneath. Today, geotechnical sensors measure rock movements of less than a millimeter. Thermal cameras detect water infiltration behind the surface. Helicopter-mounted LiDAR systems create millimeter-accurate 3D maps of entire cliff faces, comparing each scan to the baseline to catch any shift before it becomes a catastrophe. The Beartooth Highway in Montana is closed more than half the year. Not because the road isn't there, but because the mountain won't allow it. The monitoring never stops, because on a cliff road, the gap between a warning sign and a disaster can be measured in hours. Now zoom out. These roads didn't just connect point A to point B, they connected entire economies. Before the Going to the Sun Road opened, communities on the east side of Glacier's Continental Divide were isolated for months every year. Agricultural products couldn't move, families were cut off from medical care and markets. The road changed everything overnight. The $1 Million Highway transformed isolated Colorado mining towns into thriving connected communities. The U.S. highway system today supports 71 million jobs and contributes roughly $17 trillion to the American economy annually. The cliff roads are a tiny fraction of that network. But they are the proof of concept, the living evidence that no terrain is truly impossible. So the next time you drive through a mountain pass, the next time your tires roll along asphalt pressed against a cliff face with nothing but empty air on one side, take a second, think about the powder monkey hanging on a rope in the freezing dark, drilling one more hole into solid granite. Think about the scaler poking a freshly blasted wall with an iron bar. Think about the engineer checking blast calculations by lantern light at 10,000 feet. These roads were not inevitable. They were chosen by people who looked at an impossible wall of rock and decided it was merely a very difficult problem. And that decision, made over and over again across a century of American engineering, built the country you live in today.